Let's learn how to solve a full problem using exact equation method. So let's do this slowly. Alright, so given a differential equation, now you want to know first whether this is an exact equation or not. So you have to do the exact equation test. To do that, you have to identify what is m and n. So what is m here in this differential equation? M is actually what is in front of dx, right? So which is 2xy minus 3x square. So that's m. Now what is n? N is what is in front of dy, which is x square minus 2y. So after you identify them successfully, you want to do the exact equation test. That means we don't know whether this differential equation is exact or not yet. We can identify m and n, but we don't know whether this m and n are created out of the same function f, right? So if you don't know that, refer my previous video to that. Okay, so what is the test? Test says if partial derivative of m with respect to y is same as partial derivative of n with respect to x, if these two are same, then you have an exact equation. Now this is something that you should remember. Now how can you remember that? There's a shortcut, there's an easy way to remember that. What is m? How would you identify m? M is what is in front of dx, right? So in the test, what you do is you take the partial derivative with respect to y, the opposite. N is what is in front of dy, so you take the partial derivative with respect to x. So that's an easy way to remember it. So if you know how to identify m and n, you can easily recall the test. Okay, so let's do the test to know whether this is exact or not. M here, so partial derivative of m with respect to y, if you differentiate with respect to y partially, if you differentiate 2xy, it's 2x, right? If you differentiate with respect to y. Derivative of 3x square is 0, right? Because you are differentiating with respect to y. Okay, so 3x square is like a constant. Now partial derivative of n with respect to x is actually, if you differentiate x square, it's 2x. If you differentiate 2y, now y is a constant here because you are differentiating with respect to x partially. Okay, so the derivative is 2x. Now they are the same, right? Yes. So the exact equation test, you passed it. Okay, so you verified that this is an exact equation. So this is exact. Then what does it mean to be exact? That means m is then you can use the definition for m. Then that means m is the partial derivative of f of some kind of a function x, and n is the partial derivative of some kind of a function f with respect to y. Not the some kind of a function, but the same function as m here. Okay, so same f. That is what we conclude if we pass the test. Now, we all knew that from last video. Now, how do you proceed from here? Now, f is the solution for the differential equation. That is what you need to find. Now, how do you find f? You need to find f. How do we find f? Let me show you. So, m we know, which is 2xy minus 3x square. N we know, x square minus 2y. So, here's how we do it. Now, m is this, and it is equal to partial derivative of f with respect to y, x. So let's write it. So pick up any equation you like from here. You can choose any one. So let me choose the first one. Partial derivative of f with respect to x is 2xy minus 3x square. Now what I'm going to do is I'm going to integrate. So see, partial derivative of f with respect to x is this one. So how can we find f? Integrate with respect to x, right? So let's integrate 2xy minus 3x square with respect to x. Okay, because we have taken the partial derivative of f with respect to x, so I will integrate with respect to x to find f. You could have used this equation also here. Okay, I just choose randomly m1, but you could have choose this one. You could have integrate with respect to y and find f also. Okay, all right, so here f is, now let's integrate. So f is going to be, if you integrate 2xy, what you get? 2x square over 2 y, right? Don't get bothered about y. Treat y as a constant. Okay? Minus, if you integrate 3x square, you get 3x cubed over 3. Now you get a arbitrary constant c. Now what is that constant c? It's constant. So y appears like a constant here. So constant is actually a function of y. So that's what we decide. Okay, so it's some kind of a function of y. Let's say call it g. So it's not a constant, it's actually a function of y. Let's simplify this furthermore. Alright, so f is actually x square y minus x cube plus function of y. Alright, now we almost done with the problem because we found f, but we don't know g. How can we find g? That's the crucial part, okay? How can we find g? We used the one fact here. Now let's use the other fact. Because according to the second fact, okay, according to the fact that you didn't use, you use partial derivative of f with respect to x. You used that fact to integrate and find f. But you didn't use this fact, okay? So you will be always using the both facts, okay? Doesn't matter which one you start, you will be using the other one later. But because of the second fact, it says partial derivative of f with respect to y, that's x square minus 2y. So we already know f. So let's differentiate f with respect to y, okay? So if you differentiate f with respect to y, if you differentiate this function here, because we already know f, if you differentiate x square y with respect to y, you get x square because derivative of y is 1. 1 times x square is x square. Minus derivative of x cube is 0. Derivative of x cube with respect to y is 0. So that's gone. Plus derivative of g with respect to y is g prime y. Right? We don't know the derivative, so let's call it g prime y. So according to the f that we used, partial derivative of f with respect to y is x square plus g prime y. But what is actually partial derivative of f with respect to y? So this should be equal to x square minus 2y, right? Because we already know partial derivative of f with respect to y. So x square plus g prime y is equal to x square minus 2y. So what happens? X square cancel out, right? So what is g prime? G prime y is negative 2y. Now the derivative of g is negative 2y. So what is g? Integrate negative 2y, right? So if you integrate negative 2y with respect to y, you get negative 2y square over 2, which is negative y square. So that is gy. Alright, so then what is f? We finish the final puzzle of the problem because f is x square y minus x cube plus gy. So f is x square y minus x cube plus gy is negative y square. Oops, I forgot. Plus c, arbitrary constant plus c. Don't forget that. Okay, so we integrate negative 2y, so we have to have plus c. So negative y squared, so gy is negative y square plus now a constant c, right? Because g is only a function of y. So this should be really a constant, not a function of x. Okay, so this is f. Alright, so that means what is the solution? Solution for the differential is f is equal to 0. That's by the definition. So your solution for the differential equation is x square minus x square times y minus x cube minus y square plus c is equal to 0. We can take this plus c to the other side and write as minus c, or we can just write as c because it's an arbitrary constant. So this is the solution of the differential equation. Okay, alright, so that's how we solve an exact equation problem. So let me recap, okay, because this is the first example. So be with me and learn how we solve the problem. Okay, first you are given a differential equation. Now figure out m and n. So m is this, n is this. Do the test. Do the exact equation test. That means differentiate m with respect to y partially, differentiate n with respect to x partially, see whether they are the same. If they are the same, continue If they are the same, that means m is partial derivative of f with respect to x and n is partial derivative of f with respect to y. Okay, all right. So now we know m. So m is actually, m is this one, n is this one. So partial derivative of f with respect to x is actually equal to m. So I took that equation. Now that means derivative of f with respect to x is equal to this function. So I integrate that function to find f. Okay, so I got f to be this particular function, but the arbitrary constant, that plus c, is a function of y, because we have taken the partial derivatives here. Partial derivative of x, we did the partial integration. Okay, so partial derivative of f with respect to x means you treat y as a constant, so that plus c, that's actually a function of y. So we already now know f, but only half, because actually our constant is an unknown function of g. So we have to find that g. To do that, we take the partial derivative of f with respect to y. To do that, we use the other fact, because we used a one fact to integrate. Now the other fact says partial derivative of f with respect to y is this function. So we already know f from here. So let's differentiate the f that we know with respect to y. So if you differentiate this part, you get x square. If you differentiate g, we don't know that. We differentiate with respect to y. So we just say it's g prime y. So we get x square plus g prime y. But supposedly it should be equal to x square minus 2y, right? Because we know that from a fact. Now from here we solve for g. G prime y, if we cancel out and simplify, g prime y, we got it to be negative 2y. Okay, so then to find g out of g prime, we integrate it again. Now again we will have a plus c, but now we only have a function of y, right? And then that plus c will be a constant, okay, because this is ordinary derivative we have taken, because it's function of just y, there's no x there. So we found the g. So we already know f half, only problem was we didn't know g. So we replace that g. Okay, we replace that g that we found in f. So g was negative y square plus c. So f is this. Now f is equal to 0. This equal to 0 is the solution for the differential equation. So I can rewrite it by taking plus c to the other side. This is the solution. So that is how you find the solution of an exact equation. All right, so the best way to learn this is to do more examples. So watch my next video where I'm solving a lot of examples. Okay, all right, and I will see you in the next video. Thank you. Bye bye.